In this video, I'll be talking about inheritance and polymorphism in Python. Let's get started. So here's a scenario. You're an architect in New York City and you're creating blueprints for different projects in the city. Remember, there are different types of buildings in and around the city. There are residential homes, there's apartments, skyscrapers, traditional office buildings, and more. But at the end of the day, they all contain similar attributes that make them a building. Attributes like doors, windows, bathrooms, and more. Because of these similar attributes, it wouldn't make sense to create those attributes multiple times when creating a blueprint for each type of building. We should create a base blueprint that includes all of the similar attributes. So this is where inheritance become useful. In code, we can create a base class, or we can call it a parent class, which allows for other classes to inherit from it. So if you remember, a class is essentially a blueprint that describes an object or an instance of an object. So when we're creating this parent class, in the future, we're essentially saying that you're allowed to take attributes from the parent class, from the initial blueprint. The classes that inherit from the parent are called subclasses, or also called derived classes. So like I said, you can create a blueprint, and that's essentially going to be called the base class or the parent class. And then you can have subclasses or derived classes that will take attributes from that parent class. So from the initial example, we talked about buildings in New York City, right? We have residential homes, we have apartments and skyscrapers. So what we could do is create a initial blueprint and allow for that blueprint to be utilized by derived classes like a home, a skyscraper, and an office building. The home, the skyscraper, and office are all considered a building because they have similar attributes like doors, windows, bathrooms, and more. And they're all extracting those attributes from the parent class. The house, the skyscraper, and the office are going to be considered the derived class because they're taking information from a parent class, but the parent class is the one that's providing the attributes to these derived classes. Another good example is just like in real life, where you could have a child that can inherit genetics like hair texture, nose size, and eye color from a parent. They may not copy all the attributes of the parents, but they could have similar structures from the parent. So hopefully that makes sense. We'll dive into the code and demonstrate how that can be done using Python code. So let's get started. So the first class that we want to create in this inherit.py file is the building class, because this is going to be the base class that all the other building structures inherit from. Because like I said, an apartment, a skyscraper, an office, a home, that's all considered a building because they have similar attributes. They're not necessarily the same, but they have similar attributes that they can take from the parent class. So let's do that. So let's do class and then give it a name of building. We're going to open up the parentheses, and what we're going to do is we're going to pass a parameter called object. And object in Python is just a built-in basic class that every class in Python inherits from. It's the root of all inheritance hierarchies. So we can pass that in for the parent class, and then we can define a initial constructor using the init. And we'll just define some value. So first it's going to be self, and then I just want to give the building some basic attributes that define a building. So like I said, we can do doors, we can do bathrooms, we can do rooms, and we can do I guess windows. Actually, I'll do value because every building has a value, right? And there can also be default values, so I could put the default value for that to be 0. And honestly, I'm just going to put 0 for everything just so it can be safe. And then I'll assign those values using self.doors is equal to doors, self.bathrooms is equal to bathrooms, and self.rooms is equal to rooms, and lastly self.value is equal to value. So cool, now we have some attributes that define a building: the amount of doors, the amount of bathrooms, the amount of generic rooms, whether that's the the oval room for the business meetings in the skyscraper, or whether that's just a normal bedroom, right? And then we have value, meaning the value of the building. So now we have a parent class that has pretty generic attributes that define a building. But now comes the powerful part of inheritance. What if we have another type of building that can utilize these attributes that are defined for the parent class, right? We want to create another class that can inherit from the parent class. So like I said, anything that takes from a parent class is called a derived class. So let's do that. Let's do class skyscraper. And then what we got to do is open up the parentheses here. And now we got to pass what we're trying to inherit from within this parentheses. So I'm trying to inherit from the base class of building. And now I should have access to the attributes that were defined in this base class. So what I'm going to do is define a constructor using init. And I'm going to open that up, provide self, and then now I can start defining attributes that make a skyscraper a skyscraper. So one thing that I think about when I think about the skyscraper is how tall it is and the fact that it has so many floors. So that's an attribute that I'm going to add for skyscraper, the amount of floors that a skyscraper has. So I'm going to make that have a default value of 0. And then now I can assign that doing self.floors. And I'm going to make that equal to floors. Now you're probably wondering to yourself, okay, I defined an attribute for skyscraper and it currently has just the attribute of floors, but how exactly do I get the attributes from the parent class? We pass it into the parameter, cool, but how do we get access to, plug and play and utilize the attributes that the base class, that we defined in the base class? Well, to do that, we can use a keyword method of super. And what this is going to do is, super just means that it's going to be grabbing essentially the parent class. So in this case, it's going to be like what we're trying to grab from is building, because that is the parent class. So if we do super and open up the parentheses and do a dot, we now have access to everything within the parent or base class. And you can see, we can see the attributes, and we can also see the initial constructor. So we want to define those values utilizing the constructor here. And we want to also take in those values in our own skyscraper constructor as well, so that we can define and plug it in to utilize within this class. So I'm going to accept doors, bathrooms, rooms, and value. But the cool thing about it is the fact that I don't have to do all of this again. All I got to do is expect the user to pass in those values, and I can just initialize it using the super keyword and utilizing the constructor from the parent class to define the values there. So cool. And I'm gonna give all of these a default value as well. And I'm gonna use decimal there, 0.0. And then cool. And then let me close that off. Nice. So then here you can see, if I hover over it, I can see that it's expecting doors, bathrooms, rooms, and value, but it's not going crazy because I have default values. So even if the user doesn't set any values here, then it's just gonna default to 0, but I'll still pass it in. So you got doors, you got bathrooms, you got rooms, and you got value. So now you can see how useful it is, because now I don't have to do all of this again. I can just pass those values in, and now I have access to it. So to see that in action, we can now create an instance of a skyscraper. So do that skyscraper, and I'm going to make that equal to skyscraper. And I can define the amount of floors. So I'm going to say this skyscraper has 40 floors. It has, let's say, 100 doors. It has 200 bathrooms, 150 rooms, and the value is currently, let's say, $10 million. Cool. Now if I just do print and I do skyscraper dot, and now I can start grabbing the different attributes within it. You can see that I have access to bathroom, doors, floors, rooms, and value. But I'll just print out the value, and I'll do Python 3 inherit pi. You can see that I now have access to the value of the skyscraper. Alright, so to make our object a little bit more readable, I created a dunder method to print out a prompt to make our object readable based on, the amount of floors, doors, bathrooms, rooms, and value. So whenever somebody print out an instance of our skyscraper instance, they'll be able to see the amount of floors, doors, bathrooms, rooms, and the value. And I'm gonna make this a capital R right here. And all I did was I just created a multi-line formatted string, and I just passed the values of each of those specific attributes for the skyscraper. So you got the floors, you got the doors, the bathrooms, the rooms, and the value, and that's all in this dunder method. 2 underscores str and another 2 underscores, then pass an instance of self to the as a parameter, and that just means self is just this instance of the skyscraper. That's all self is, right? So if I go back and I do print, and I just print out the instance of the skyscraper because I don't feel like doing dot value dot rooms for each individual piece, you can just print out the skyscraper instance itself. If I do that, and I do python inherit.py, or actually in my case it's going to be python 3, and I run it, you can now see that it's printing out a formatted string of everything about the instance of that object that was created. So just to give a little recap, we created a skyscraper derived class that's inheriting from building. We took in floors as a new attribute for skyscraper because that's unique to skyscraper. Well, the office can have multiple floors as well, but when I think of a skyscraper, I think of a 40, 50, 60 floor building. And there's also other attributes of skyscraper that you could put, but that's up to you. That would be a little addition for your class. But also, I'm asking the user to pass a door, the amount of doors, the amount of bathrooms, rooms, and value. But I'm not actually creating that within skyscraper. I'm actually using the inherited constructor from the building parent class and passing those values through there. And I'm using the super keyword to reference the parent class. But I'm also still defining floors for skyscraper. But as you can see, it's less work because all I got to do is use the keyword to initialize those attributes. I don't have to rewrite that code over and over and over again. So you can see the power of this if I have 10 similar buildings, right? Instead of having to create an attribute or the same attributes over and over again, I can just inherit from it and then use the super keyword to create or to utilize that constructor by passing those values in the constructor. And then I can just print out, information regarding that class. In the cases maybe Zillow might need that information, right? As you can see, the power of inheritance, and we could do the same thing. And I'm not going to write out the code slowly. I'm just gonna paste in another example that I would like to give is, say for instance, we have an apartment building. Well, let me just paste that in because just to save time. But and I'll erase value because we already have value. But we have an apartment building because an apartment building is still a building. And one thing specific to apartments is the amount of units that an apartment can have. Remember that an apartment building is a building, but it can have subunits for different individuals to live in it. Different families can live in an apartment that can be 20 rooms for 20 different families or 20 individuals. So I can still utilize super to get or to utilize the attributes created for the parent class, such as the amount of doors, bathrooms, rooms, and values, but I can also specify the amount of units as well. So yes, a unit can have 2 rooms, 1 bathroom, but I want to know the amount of units in general. Are there 30 different units for people to be able to buy from? Or are there 10, 20, or maybe just 1, right? I want to be able to provide that information. That's what makes an apartment. So that's why I'm expecting that in the initial constructor for the apartment, and I'm assigning it to units. But then I still want to know information regarding the apartment building, such as the amount of doors, bathrooms, rooms, and the value in totality for that apartment building. So I can do that here. And I'm just gonna take from the skyscraper pretty much all of this, the doors, value, all of that initially. And I'm just gonna paste that here in the init. And then now I can also do the same thing here where I can pass those parameters in the init. And my little comment here says super references the parent class, which it does. We initialize the constructor in the parent and the child has access to it. That's exactly what it does. Right? So now we have another derived class called apartment that we can utilize. So let's do that now. So let's do apartment and make that equal to apartment, or an instance of an apartment. And now we can define the amount of units. I'm gonna say that this is a pretty big apartment. It has 80 units. It has, let's say, if it has 80 units, let's say it has 160 doors in totality of the apartment. And then let's say that it has about 180, let's be realistic, let's say 180 bathrooms. Let's say that it has about 100 rooms, including like the janitor rooms and all that, custodial rooms, and then the value of it, it's a pretty big apartment. It has a lot of cash flow. Let's say that it's about a $20 million building. Right? So now we can do the same thing where we can take this dunder method, bring that to, and if anything, we can even put the dunder method inside of the building as well. But I'm not going to do that. I'm going to put that in apartments, and I'm just going to change it to return that. And let me make sure that it's formatted properly. Put that to the side. But now, instead of it having floors, we can just put units and then do self.units here. And now when we print out an instance of apartment, we should now, and I'm coming out the skyscraper one, and run Python 3 inherit. And now we can see a message regarding the apartment instance. It has 80 units, 160 doors, 180 bathrooms, 100 rooms, and has a value of 20 million. So cool. Another thing that we can actually use is the dunder method of dict. So we could have just did dict, and let's run that again, and it will show the value of each attribute within that object instance. So either or works, but if you want like a nice string representation of your object, then you could create one using the str dunder method. And it doesn't have to be in this exact format. It could be whatever format that you want, but either or works if you want to see what's going on inside of your object instance. With inheritance, we now have the ability to inherit all the data fields and methods from a parent class, while also having the ability to add our own methods and data fields, which makes a subclass a bit different from the parent. So this saves a lot of time when each class are similar but not exactly the same. So like I said, with the methods, we could do essentially something similar, right? It doesn't have to be the dunder method. We could literally just make this a method called prompt, right? And this can be prompt as well. And I'll paste that here and call this prompt, right? And we're gonna make this a bit generic. We're gonna make this just with doors, with the attributes that it has, right? And do that to remove units. And say for instance, we actually never created a prompt for apartment, right? So let's comment this out. We still have access to prompts, by the way, because of the fact that it inherit prompt from building, right? It's still a child class of this parent class, so we can still, and let me just clear this out. We can still print it. It's just not going to have units, right? It's not going to have the attribute of what makes an apartment, but we do still have a generic prompt that we can grab from the base class or from the parent class, from the child class, right? But say for instance, we have our own version of prompt and we run this again. Boom, we see that it pretty much ignores the parent class and just prints out the version that we expect, which is coming from the apartment class. So essentially what we're doing is we're overriding the method from the base class inside of the subclass. And for it to work, you just got to make sure that the methods have the same signature, meaning it's identical in naming and parameters as the one in the parent class, as the one that we created in the child class. So as you can see, it's still called prompt. It still only takes one parameter, just like the one in the base class. But if we were to just add an attribute here, like add another value here as a parameter, then these are two different methods, and we're not overriding anything because they're two different methods. They're not the same signature. But if we're trying to override a method that was created in the base class, then all we got to do is match the signature in the child class, and whenever we call it, it's just going to take the child class version of it. But creating a method like this in the base class is useful in cases where you don't necessarily need it for the child class, but you want to print out or utilize the attributes that are in the parent class. For an example, like in this case, you just want to print out doors, bathrooms, rooms, and value, but maybe you might not want to print out the units, so you just leave that out, or you just use the base version of that method. Now, the cool thing about Python that makes inheritance different from major languages like Java and C++ is the fact that you're allowed to inherit from multiple classes in Python, unlike, like I said, Java and C++. And in Java and C++, there's only one, that's it. But in Python, we can do multiple. So let's see. So just like I did before, I'm not going to write it all out just to save time, but we do have a apartment child class, and if you ever live in an apartment, you know that things could go wrong, so occasionally you may need maintenance. And what I'm going to do is I'm going to create a maintenance class, and this is going to allow us to make a maintenance request and log and see the amount of times that we made a request based on this specific apartment instance. And like I said, we're able to inherit from multiple parent classes, so that's exactly what I'm going to do. So we already inherited from building for apartment, but now we can inherit from maintenance, because of the fact that maintenance can be done anywhere. It can be done in a skyscraper as well if we needed to, and it can be done in really any building that serves or provides spaces to multiple users, right? Because things do break, so sometimes you have to make a request to fix things. So maintenance is a pretty good parent class to create if you know that the structure is going to be same for multiple child classes. You know that multiple classes can utilize what's inside of the parent class, then that usually means that it's a good idea to make it. So I know that an apartment, or really any building, can have maintenance that need to be done. Usually if it's your own home, then you're probably going to have to create your own or do your own maintenance, or maybe you might need a third party. But in apartments, it usually comes within the service that you already have a maintenance person on your staff that handles, maybe a faucet doesn't, close all the way, or maybe the shower doesn't work. So here for maintenance, I have an attribute called amount of requests. So every single time a request is made, I want to increment it, and I want to log the requests that were made from that specific instance of maintenance. So every single time somebody makes a request, it's going to take the request, it's going to save the last request, and it's going to increment the amount of requests, and it's going to append the request to the request log. Useful stuff, just in case anyone ever gets audited, or people need to know what exactly is going on, or maybe the person in charge of maintenance of whatever building is utilizing this maintenance service. We can see what needs to be done, and maybe in the end pop out that request when it's actually finished. There's a lot of things you can do with this. So now that we inherited maintenance, because all we got to do is use a comma and pass maintenance as a parent class that we're going to inherit from, because we're able to inherit from multiple parent classes, like I said multiple times, we can utilize it down here. So let's do apartment, and let's do make request. As you can see, we have access to make request now. That was created in this maintenance class, and what's it expecting? It's expecting a string, right? A string of request. And what we're going to do is we're going to say that there's a faucet leak, and we're going to make another request. So it's going to be apartment dot make request, and we're going to say we're going to need bug control. There's an issue with bugs around the apartment. And now, let me comment this out. I'm going to print out apartment dot request log, because now we have access to request log, because in maintenance that is also available, right? We have the amount of requests that we can print out, and we have the request log. So we can actually just print that out as well. Let me just do print apartment dot amount of requests. We have access to both. Now if you want to encapsulate it and hide it, you can do that as well, but just for this example, I want to print that out and see how many requests are in the system and the logs of the amount of requests. So let me run this, and boom, you can see that there are 2 requests. There's a faucet leak and there's a bug control issue. So you can see the power of this, right? And the list can go on, right? Because you can add another class or parent class that we can inherit from, and it can do something completely different, right? For like payments, for like every unit has to put in a payment, so you can have an array of each unit that are being utilized by a party, and at the end of each month see who paid, right? So there's many things that you could do with this, but it's just the power of inheritance and polymorphism. And just to dive into polymorphism a little bit, because we utilized it and we didn't even know, but in Python, polymorphism refers to the occurrence of something in multiple forms. So just due to the nature of polymorphism, a Python child class can have methods with the same name as a parent class method, but different in execution. So we went over that, right? We had this prompt method with the same signature, but it was different in execution because the values were different. We did some overloading because yes, the signature was the same, and yes, they're both buildings, but we utilized overloading to use the prompt method that was created within apartments. But because it's a building, even if we were to remove this overloaded version of the method, we'll still have access to the building version of it. So it could take on multiple forms. It could be an apartment, but at the end of the day, an apartment is also a building. Different forms, and that's the power of polymorphism. So that is inheritance and polymorphism in Python. Thank you for watching. Go ahead and leave a like and subscribe if you found that helpful. And if you want more Python content, go ahead and do that. Leave a like, subscribe, and hope you found that helpful. And if you have any questions, leave it down below. Thank you.